What if I told you nothing in this universe has properties of its own? Not position, not spin, not even existence. Everything only exists in relation to something else. From the moment we can make sense of the world, we're taught to see it as a collection of things. There's you, then there's everything else out there, separate, independent. Your chair, the air you breathe, the distant stars. And we learn that if you could zoom in far enough, all of it is just swarm of tiny fundamental particles, little marbles of matter bouncing around in a vast empty box. It's a story about all objects, a story of separation. But what if that's the biggest illusion we have ever bought into? What if the science's deepest look into the heart of reality has found the exact opposite? What if the most fundamental rule of the universe isn't about particles themselves, but about their connections? And what if that secret could change how we see everything, from the cosmos to our own lives? This isn't just a philosophical fantasy. It's the core of a revolutionary idea in physics that challenges what it even means for something to exist. A theory that suggests reality isn't a pile of things, but a shimmering, intricate web of interactions. For centuries, the classical view of the universe, perfected by Isaac Newton, reigned supreme. It was simple, it was intuitive, and it worked. A ball has a position, a speed, a mass, and those properties exist whether we are looking at it or not. In this picture, the universe is a grand clockwork machine, predictable, objective, and independent of us. If you knew the state of every gear, you could calculate its entire past and future. It was a world built on comforting certainty. But then, at the turn of the 20th century, we started peering into the subatomic realm, and that clockwork universe began to shatter. Physicists found a world so bizarre, so alien to our common sense, that it deeply troubled them. They discovered that particles like electrons don't seem to have a definite properties until they are measured. Before you look, an electron isn't at a point A or a point B. It exists in a ghostly haze of possibilities, a superposition of all its potential locations at once. The act of interaction, of observation, seems to force this ghost to pick one spot, to snap into a single concrete reality. How does a particle know it's being watched? And what even counts as an observer? Does it have to be a conscious human, a machine, or a speck of dust? This puzzle is called the measurement problem, and it's a deep crack in the foundation of the physics. For 100 years, this question has haunted the field, and the rabbit hole goes deeper. The most famous quantum paradox is entanglement. Imagine two particles linked in a special way. Send them to the opposite end of the universe. Quantum mechanics predicts they remain connected. If you measure a property of one, say its spin, you instantly know the spin of the other, no matter how far apart they are. Albert Einstein famously called this spooky action at a distance because it seems to break the cosmic speed limit, the speed of light. The information appears to travel between them instantly. But that's actually not what's happening. This spooky connection isn't just a theory, it's a proven experimental fact and deals a devastating blow to our classical intuition. For decades, physicists have wrestled with these paradoxes, proposing mind-bending solutions like infinite parallel universe or hidden variables we just can't see. But what if the problem isn't with the theory, but with our most basic assumption? What if the properties like spin, position, and even existence itself aren't built into an object? What if they only come into being in relation to something else? This is the radical but beautiful idea at the heart of relational quantum mechanics, or RQM, developed by Italian theoretical physicist Carlo Rovelli. RQM proposes that the physical world is not about objects themselves, but about relations between them. It tells us to abandon the idea that anything has absolute state. independent of an observer. To get a feel for this, think about something simple: velocity. If I ask you, what is the absolute speed of that car? The question is meaningless. Is it 60 miles per hour? But relative to what? Maybe relative to road. 700 miles per hour relative to Earth's center, or 67,000 miles per hour relative to sun. Velocity isn't a property of the car. It's a property of the relation between the car and something else. Rovelli suggests that quantum mechanics is screaming that all properties work this way. An electron doesn't have to have definite spin in some absolute sense. It only gets a spin relative to the system it's interacting with, the measuring device, for instance. So, what about the spooky action at a distance? From the RQM perspective, the paradox vanishes. Let's say two observers, Alice and Bob, share entangled particles. Alice measures her particle and finds its spin as up. In that instant, for her, the reality of the system has changed. Her interaction has established a fact relative to her. But what about Bob, light years away? For him, nothing has happened. From his perspective, the whole setup, Alice, her lab, and both particles, is still one giant, undecided quantum system. No information has magically traveled to him. A definite fact about his particle will only be established when he interacts with it. Now, according to RQM, both Alice's and Bob's story are correct, but from their own viewpoint. There is no single God's eye view of reality. There's no absolute objective truth of matter. Reality in this view is a vast network of perspectives. Every interaction creates a new set of facts. The state of a system is just the summary of its past interactions, which we use to predict the future ones. RQM proposes that things don't just have properties sitting there waiting to be found. Properties are manifested, brought into being through interactions. The world at its most fundamental level isn't made of things, it's made of happenings. It's a world of events, not objects. Now, this is where a theory about subatomic particles provides a shocking new lens for the human experience. If the fundamental nature of physical reality is relational, what might that imply for us? We too are physical systems made of same quantum stuffs as everything else. The implications are fascinating to consider. This framework offers a powerful scientific metaphor that challenges our common sense notion, a self-contained mind looking at a separate external world. Think about who you are. Are you defined by a fixed list of built-in properties, or are you a dynamic flowing product of your relationships? You are a different person to your mother than to your best friend. You are a different person to your boss than to your child. Every relationship seems to bring in different version of you into being. This doesn't make any of these versions less real, but it just means that they are different, context-dependent truths. RQM provides a compelling scientific parallel to this human truth. Just as different observers in quantum mechanics can have different, equally valid accounts of event, the different people in our lives hold different, equally valid perspective of who we are. So much conflict in our lives comes from assuming that there is one absolute truth, my truth, and that all other views are wrong. But relational perspective suggests empathy isn't just a nice feeling, it's an acknowledgement of how reality might be structured. It's the understanding that another person's reality relative to them is as valid as your own. In physics, repeated interactions build up a stable classical world we can all agree on. In same way, consistent interactions in our lives build a stable relationships and a shared sense of community. Trust is the history of correlated interactions. Love isn't a static property, but a continuous dynamic process of relating. This way of thinking challenges the radical individualism that has dominated so much of modern thought. It suggests that, like those entangled particles, we are not separate as we feel. Our connections to others aren't just an important part of our lives, they may be the very fabric of our being. And what about consciousness? Many quantum theories have struggled with the consciousness, giving it some special, almost mystical role. RQM gracefully sidesteps this. An observer isn't necessarily a conscious being, it can be any physical system at all. A photon hitting an electron, a rock hitting the ground. These are all interactions that established relative facts. From this viewpoint, consciousness isn't a magical force outside of physics. It's simply an emergent property of a fantastically complex physical system, our brain, participating in this cosmic dance of relations. It doesn't cause reality, it is a manifestation of it, an intricate knot in the universe web of interactions. So let's go back to the beginning. What if the reality isn't built from particles but from relationships? Relational quantum mechanics offers a powerful and elegant answer. It takes the strangeness of quantum world, superposition, measurement, and entanglement, and reveals them not as paradoxes but as the fundamental grammar of the universe. The world isn't a collection of things, it's a network of interactions. Properties aren't built in, they are relative. Facts aren't absolute, they are perspective. It's a vision that dissolves the hard line between a thing and its environment, between an observer and the observed, and ultimately between you and me. This isn't just abstract physics, it's a new lens of seeing the world. It suggests that nothing exists in isolation. Everything is defined by its connections. It paints a picture of a universe that's less like cold machine and more like endless conversation. It asks us to look at our own lives and see the profound truth of our human instincts. Having always known that we are defined by our relationships, our connections with family, friends, and the world around us aren't secondary to who we are, they are who we are. They are the interactions that give our lives meaning, context, and reality. The old physics told us we were separate objects, adrift and alone in the cosmos. This new view tells us that we are inseparable threads in a magnificent, interconnected tapestry. And maybe understanding this isn't just secret to quantum mechanics. Perhaps it's a secret to a more loved and connected and meaningful life. But what do you think of it? Does this relational view of reality resonate with you? Does seeing the universe as a web of interactions change how you think about your own place in it? Share your thoughts in the comments below. I'm genuinely curious to hear from your perspective. And if you are fascinated by these explorations into the nature of reality, make sure to subscribe and turn on notification. We have so much more of the cosmos to explore together. And thanks for watching.